Welcome back to the deep dive. It is February 2026, and if you've been anywhere near the automotive internet lately, you know exactly what we are talking about today.
Oh, yeah.
The Rivian R2 is finally, officially here. And I have to say, looking at the coverage, the hype machine is fully operational.
It certainly is. I mean, we've been seeing the camouflage photos and hearing the rumors for what feels like years.
Right.
But now we have the actual specs, the reviews from people who've driven it, and, the hard reality of what Rivian's trying to pull off.
Right, and that's where I want to start. Everyone is calling this the Model Y fighter. It's the headline on every article.
Yep.
But I feel like that label is a bit lazy. Is it actually trying to be a Tesla, or is it trying to be something else entirely? Because just looking at it, it doesn't scream Silicon Valley tech pod to me. It looks rugged.
And that is the core tension we need to explore today. Our mission is really to strip away that marketing fluff. We've got a stack of sources for Drive, reviews from Road and Track and Doug DeMiro, engineering breakdowns from Autoblog, and some very specific international reporting. We need to look at this with absolute simplicity and clarity. Is this just a smaller, cheaper R1S, or is it a fundamentally different machine?
And more importantly, is it a machine that can save the company? Because the stakes here are incredibly high.
They really are.
But before we get into the, live or die financial stuff, let's talk about the actual car. Because there is one feature that every single review is obsessing over, and honestly, I'm trying to decide if it's genius or gimmick.
You're talking about the interior seating configuration.
Damn, the camping mode. I mean, we're used to rear seats folding flat. That's table stakes for an SUV.
Sure.
But Rivian claims every single seat in the R2 folds flat, even the driver's seat.
Correct. Both front seats fold forward and down.
Okay, walk me through the utility of that. Because usually when a front seat folds, it's a clunky, uneven mess. Road and Track tested this, right?
They did. And what they found is that it creates a mostly level surface running the entire length of the cabin.
Mostly level.
They specifically mentioned that a 95th percentile male can lie completely flat inside the car with the tailgate closed.
Wait, 95th percentile? That's a tall person.
It's huge internal volume relative to its footprint. But to your point about gimmick versus genius, just think about the use case.
Go on.
If you're a climber or a surfer or just someone driving cross-country, the ability to turn your car into a hard-shell tent without any external gear, that's a significant value add. You just pull over, drop the seats, and sleep.
Sure, but is it actually flat? Or is it flat with a giant lump in your lower back where the hinge is?
That is the catch. The reviews note there are slight indentations where the rear fenders encroach, and there is a gap between the front seats where the center console lives.
Oh, okay.
It isn't a mattress. You'd still want an inflatable pad to bridge those gaps.
See, that's what I mean. It's cool, but maybe not quite as seamless as the photos look.
Yeah.
And speaking of seamless, Road and Track had a funny point about why Rivian didn't call this stow laud go.
Well, Chrysler lawyers would definitely have something to say about that trademark.
Oh, great.
But they also pointed out the obvious logistical flaw. Going becomes quite difficult once you stow the driver's seat.
You can't drive the car while you were sleeping in it. Not yet, anyway.
Not yet.
But this folding trick speaks to a bigger engineering challenge. The R2 is significantly smaller than the R1S, right? It's not a massive truck.
It's about 15 inches shorter. In the car world, that is a full-size class difference.
Wow.
But here's the engineering nuance. Despite being 15 inches shorter on the outside, it actually has more second-row legroom than its big brother.
How is that possible? Usually when you shrink the car, the back seat is the first thing to suffer.
It all comes down to packaging efficiency, specifically with the HVAC components and the glove box area. They basically pushed the dashboard forward and thinned out the seat backs. It's a game of millimeters.
Speaking of the glove box, I read about the second glove box, or well, the drawer.
The center drawer, yes.
Apparently, it's sized specifically for a tissue box. That feels like such a specific, almost grandmotherly detail for an adventure vehicle.
It came directly from customer feedback.
Okay.
People kept putting tissue boxes on the dash or the floor, and they'd slide around.
Ah.
So Rivian built a drawer for it. It seems trivial,
Yeah.
but it signals that they're listening to how people actually live in the car, not just how they drive it.
I can appreciate that. Now let's move to the outside because there's another feature that's getting a lot of attention, and it feels like a direct nostalgia play for Toyota 4Runner fans.
The rear window rolls down.
The drop glass, it's iconic on the 4Runner, and Rivian has adopted it here.
Yep.
Is this just for carrying surfboards, or is there a real benefit?
Well, it's absolutely functional for airflow.
Yeah.
But I want to pause on this because it's a great example of how hard simple features are to
Okay.
engineer.
Okay.
Think about the rear wiper on a normal SUV. Where is it?
Usually attached to the glass at the
Mhm.
bottom.
Right. But if the glass has to disappear inside the middle tailgate, you can't have a motor and a wiper arm attached to it.
It would smash into the door mechanism.
It would completely smash it, so they had to move it. They mounted the wiper mechanism in a holder below the window, but then they had to engineer a specific drain system.
Oh, I didn't even think of that.
When you use the washer fluid, or when it rains, that water has to go somewhere. They had to road drainage channels around the window motor and up beneath the taillights.
That sounds like a lot of complexity for a window that opens.
It is. And complexity adds cost. So deciding to include this means they had to save money somewhere else. It was a deliberate choice to prioritize vibe and utility over manufacturing simplicity in that specific area.
They also added that 5X switch, right? The button that drops all the windows at once.
Yes, all 4 windows plus the rear glass. It creates an open-air experience without removing the roof.
Mhm.
And you couple that with the rear compass vent windows that pop out, and you get a massive amount of passive airflow.
Okay, so we've established that the car is cool. It has the camping seats, the roll-down window, the tissue drawer, but now we have to get to the hard part. The price.
$45,000.
That's the starting price. The R1S was nearly double that. You can't just cut the price in half by removing a few speakers and using cheaper plastic.
No,
You have to fundamentally change how the car is built. How did they do it?
this is where we need to talk about Maximus.
It sounds like a character from Gladiator.
It's the name of their new in-house drive unit. And this is the single most important component in the R2 story. The specs are impressive. 0 to 60 in 3.6 seconds, 656 horsepower.
That's fast.
But the speed is just a byproduct. The real innovation is the cost reduction.
How much cheaper can a motor really be?
Significantly. Rivian claims the Maximus unit is 40% more power dense than their previous unit, but they reduced the number of fasteners by 30%.
Fasteners? You mean screws and bolts?
Exact.
Why does that matter? A bolt costs a few cents.
It's not the cost of bolt. It's the cost of the process. Every fastener requires a hole to be drilled and tapped. It requires a robot or a human to insert it.
A torque tool. A quality check.
Exactly. And over time, it's a point that can vibrate loose.
So by deleting the bolt, you delete the labor, the tool, the time, and the failure point.
Precisely. Removing 30% of the fasteners across hundreds of thousands of units saves millions of dollars.
Wow.
They also use what they call a continuous winding e-machine.
Okay, talk to me like I'm 5. What is continuous winding?
In a traditional electric motor, you have lots of separate copper coils that need to be welded together.
Right.
Each weld is a manufacturing step. Continuous winding means they wrap the copper in a way that minimizes breaks. Fewer welds, faster production, better reliability.
Okay, so the motor is cheaper and easier to build. But what about the car itself? The R1 was a tank. It was body on frame, like a Ford F-150. Is the R2 built the same way?
No, and this is the biggest departure. The R2 is a unibody vehicle.
Like a Honda CR-V or a Model Y?
Correct. The body and the frame are one piece. This sheds a massive amount of weight, roughly 2,000 pounds less than the R1S.
2,000 pounds.
And it makes the car cheaper to stamp and weld. But it also changes the character of the vehicle.
It probably rides better on the highway, I guess.
It does. Unibody vehicles are generally stiffer and handle better on pavement, but you lose some of that extreme off-road articulation you get with a separate frame.
And I noticed they dropped the air suspension. The R1 was famous for that. You could raise it up for rocks and lower it for the highway. The R2 uses springs.
Traditional coil springs. Again, a massive cost saving. Air suspension is complex, expensive, and prone to leaking.
True.
Coil springs are just metal. However, they are using active dampers.
So it can still adjust the ride stiffness?
Yes. The shock absorbers can firm up or soften based on the road surface, but the ride height is fixed. You have 9.7 inches of ground clearance, and that's what you get.
9.7 inches is still a lot, though. That's more than a Subaru Outback.
It is significant. It validates the adventure claim. It's not just a mall crawler.
Let's talk about the battery. Because if the motor is the heart of the car, the battery is the other heart. They're changing the battery tech completely.
They are. They're moving to a new cell form factor called the 4695.
I know Tesla uses the 4680, so these are bigger.
Taller. 46 millimeters wide, 95 millimeters tall.
Why taller? Does size matter here?
In batteries, volume absolutely matters. These cells hold roughly 6 times the energy of the older 2170 cells.
6 times the energy per cell, so you need way fewer of them.
Exactly. If you need fewer cells to get to a 300-mile range, you have fewer steel cans, fewer electrical connections, less packaging material.
It simplifies everything.
It does. But there's a technical challenge with taller cells.
Which is?
Heat. A taller cell is harder to cool because the heat has further to travel to get out.
So how do they stop it from overheating?
Well, they had to redesign the thermal management. The engineering details suggest they have optimized the cooling to run along the axial length more efficiently. This is crucial because better cooling means the battery degrades slower over time.
So in theory, this battery should last longer than the ones we have today.
That's the indication. And because the cells are so large, they provide structural rigidity. The top of the battery pack effectively becomes the floor of the cabin.
You're standing directly on top of the energy source. That sounds safe.
It is standard practice now. It makes the car stiffer and lighter, but it does mean if you damage the battery, you're effectively damaging the frame of the car. Repairability becomes a question mark.
Right. Now, I want to pivot to something that sounds risky to me. We talked about simplifying the motor and the battery, but they also simplified the computer. I read that they went from 4 chips down to 1.
This is the zonal architecture shift. In the previous generation, they had 4 main computers. Now they've consolidated everything onto a single central compute platform.
1 chip for the infotainment, the autopilot, the wipers, everything.
Everything.
Okay, I'm going to play the skeptic here. If that 1 chip glitches, does my car turn into a brick doing 70 miles per hour on the freeway?
That's the immediate fear. But the reality is that they use virtualization. Think of it like a computer running multiple operating systems at once that can't talk to each other.
Okay.
The software that runs the brakes and steering is in a protected zone that the infotainment software cannot touch. So even if Spotify crashes, the car still drives.
But if the physical silicon fails...
Then yes, you have a problem. But the argument is that one high-quality liquid-cooled chip is less likely to fail than 4 separate chips with miles of wiring connecting them. It eliminates the handshakes between computers, which is where a lot of bugs happen.
And this chip is powerful.
Extremely. They quote a metric of 200 sparse TOPS.
Sparse TOPS, explain that.
TOPS stands for tera operations per second. It's how many math problems the AI can do. Sparse refers to a method where the AI ignores the zeros in the data.
Ignores the zeros.
In visual data, like what the cameras see, there's a lot of empty space or irrelevant information. Sparse processing allows the chip to skip the empty parts and focus only on the relevant pixels.
So it's working smarter, not harder.
Exactly. And that processing power drives the new safety features. Did you see the blind spot integration?
The camera feed in the dash.
Yes. When you hit the turn signal, a live video of your blind spot appears on the screen in front of you. Hyundai and Kia have done this, and it's honestly one of the best safety features on the market.
Yeah, that's a great feature.
And they also added those haptic wheels on the steering wheel.
I'm usually against putting too much on the wheel, but these seem useful.
They're dynamic scroll wheels.
Yeah.
They don't just spin, they give you clicky feedback that changes depending on what you're controlling. You can use them to adjust the climate control without looking at the screen. You feel the clicks.
That is a huge win. I hate digging through menus just to turn down the heat.
It keeps eyes on the road. It's a perfect example of technology solving a problem that technology created in the first place.
So we have a simpler, cheaper, potentially more reliable car. The big question is, when can people get it? Because Rivian has had, let's call them timeliness issues in the past.
Yes. If you're in the US, the news is solid. Launch is confirmed for spring or summer 2026. The factory in Normal, Illinois has been expanded.
And for our international listeners.
This is where the strategy shifts. We looked at reports from Europe, specifically Italian automotive sources, and they are forecasting a delay.
How long?
Likely until 2028.
2 years later. That feels like a missed opportunity. The Model Y is dominating Europe right now.
It is, but Rivian is playing the long game. They are terrified of repeating the production hell of the R1 launch. They want to perfect the manufacturing of this unibody, single-chip, fastener-light vehicle in Illinois first.
Stomp out the bugs before they go international.
Exactly. It's frustrating for European buyers, but financially it's the disciplined move.
It makes sense. Better to be late and good than early and broken.
Precisely. And speaking of the Model Y, we have to make that comparison. If you have $45,000, why buy the R2 over the Tesla?
The Tesla is more efficient, right? It's aerodynamic as hell.
The Model Y is an efficiency monster. It will likely get better range per kilowatt hour. It's smoother through the air.
Mhm.
But the R2 has 9.7 inches of ground clearance versus the Tesla 6.6.
That's a massive difference.
It defines the vehicle. The Model Y is a car that looks like an SUV. The R2 is a utility vehicle that happens to be electric. If you actually drive on gravel, dirt, or snow, the R2 is physically more capable,
It's a mass market adventure vehicle.
whereas the Tesla is a mass-market transport vehicle. And the European competitors, the ID.4s and the like, they're leaning into traditional luxury.
Mhm.
Rivian is leaning into software and utility.
Hmm.
They're betting that people want a tool, not just a plush room.
It's a fascinating pivot. They aren't trying to out-luxury the Germans or out-tech Tesla. They are trying to out-adventure everyone.
That's the brand identity. But I want to leave you with a provocative thought about that one-chip architecture we discussed.
Go for it.
Rivian is bringing almost all development in-house. The motors, the batteries, the software, the ECU. They are betting that they can write code as well as they can bend metal.
Okay.
With the R2, the car has become a software-defined device.
Mhm.
So if the car is just a single computer that controls your movement, your safety, and your environment, is the car of the future actually just a computer that you can sleep inside?
Ah.
And if so, are we ready to trust a startup software company with our physical lives in the middle of the woods?
That is a haunting way to put it. A computer you sleep inside. I'm going to be thinking about that next time I'm considering a software update.
It's the reality we're driving into.
Well, on that note, we want to say a massive thank you to you, the listener. We know you have a million things to listen to, and we really appreciate you spending some time with us to unpack the R2.
Yes, thank you for your time and attention. We hope this brought you some simplicity and clarity on what is a very complex machine.
Stay curious, stay skeptical, and we will catch you on the next deep dive.